Good morning. Let's look at the weather setup for Darwin, the 24th of November, 2025. This analysis was conducted at 12:55 Australian Central Standard Time. We've got surface temperatures currently at 30 degrees, heading to a top of 30, quite humid. If you find this analysis helpful, please like and subscribe to support continued severe weather analysis. Starting this morning, we can see how the atmosphere is set up. The atmosphere is relatively calm, with only 624 joules per kilogram of available energy. It's incredibly humid. 55 millimeters of moisture is making everything sticky, feeding into potential storms. Winds are shifting with height at about 8.7 meters per second, which will organize any storms that develop. Storm clouds will form low, around 675 meters up, giving us a sense of where the action will start. Through the afternoon, conditions will stay relatively unchanged, with energy holding near 2,527 joules per kilogram. Looking at surface-based CAPE specifically here, which shows 2,527 joules per kilogram, notably higher than the mixed layer value due to strong surface heating. The atmosphere is uncapped today, meaning storms can develop freely once heating triggers convection. Expect peak instability between 2 and 4 in the afternoon. That's prime time for any storm development. Looking at tomorrow's late morning forecast from the GraphCast model, that's midnight UTC, around 10 or 11 a.m. local time. This shows how the atmosphere will be set up heading into the afternoon heating period. Notice the temperature and dew point profiles. This baseline structure tells us what ingredients will be available as the day progresses and the sun does its work. Now here's the afternoon forecast. 6 a.m. UTC is mid to late afternoon local time, around 4 or 5 p.m. This is peak heating time, maximum instability. The model shows how solar heating has reshaped the boundary layer, surface warming, mixed layer deepening, and whether that cap has weakened enough. This snapshot captures the window when storms are most likely to fire. This evolution chart shows today as the peak day. Notice how CAPE sits at 2,527 joules per kilogram today, then drops to 923 tomorrow as the pattern weakens. The models show all parameters declining after today. If storms are going to happen, today's your window. Should storms organize, we'd be watching for the potential for hail up to 3 centimeters and heavy rainfall with any storms that develop. Any storms that do form could be organized, though supercells are a long shot. The hodograph shows moderate wind turning with height, not textbook supercell structure, but enough organization for stronger storms to take advantage of, with the bunker's right mover vector showing supercells would track toward the south-southwest. Remember, these are the ingredients, not the forecast. Always check the Bureau for official warnings. This atmospheric refractivity profile shows how radio waves bend through different layers of the atmosphere. It's critical for VHF and UHF propagation forecasting. When you see sharp gradients in the end profile, that's where radio ducting occurs, allowing signals to travel hundreds of kilometers beyond normal line of sight. These same stable layers also tell us where the atmosphere resists vertical motion, which matters for storm development, but the primary application here is understanding long-distance radio propagation conditions. Remember, this is just an analysis. Always check the Bureau of Meteorology for official warnings before making any decisions. This analysis is provided by Distant Curve Remote Area Telecommunications. If you found this helpful, please like and subscribe to support continued severe weather coverage for remote Australia. Stay safe and stay weather aware out there.